Yeah, hello everyone. So we want to talk today about what we built together with Conrad and how we move them from a static infrastructure to a continuous delivery in the cloud, especially with Kubernetes. My name is Sebastian Scheele. I'm the co-founder of Loodse. We are a startup from Hamburg who's mainly working on Kubernetes.
Yeah, my name is Thomas Weidner. I'm a DevOps engineer in Conrad Electronic, and I was part of the core team for that project. Yeah.
So where all this comes from? So when we got in contact with Conrad, there was the idea to be more flexible, to be faster in the development, to set up a proper CI/CD. And there was also the decision to move out from a managed data center into the Google Cloud. And we started with this vision, so build up a CI pipeline and build up a proper, build up the infrastructure on cloud. We started at the beginning with a POC to see, okay, how we can move the existing application into the cloud. Came up with the idea, containerized everything, and run this on Kubernetes, do a POC to test if this is a valid way to go. And also pushed on the side that it's not only about the technology, so you also must talk about how to optimize your process, how to support your developers to moving in a new environment, and that the new flexible infrastructure can be really used, and because it's not enough to only have a new infrastructure and you follow your old processes. And so we start also thinking about how we can optimize the processes, how we can change the development flow. Then we starting with rolling out the components, putting first things on Kubernetes and turning this over. And today we will talk mostly about the technology side, so about the POC, what we built and how we use Kubernetes to build up a flexible environment so that each developer can push their features independently without binaries and waiting for much improvement. So yeah, shortly about the process, where we come from. So it was really, it was divided, the front end and the back end, and we had the developers, the operation, and then we had the hoster, and now we want to flip the model more in a vertical area so that each team is responsible for a complete way, so from the front end to the back end for one feature. And but for this we really also need, or Conrad needed the possibility to have a flexible environment to do all these features and build these features fast enough, and not waiting for a system landscape. So this was the current situation at Conrad. At that time when we started the project, in general, of course, each developer had his local environment, but then there was one integration system or two integration system. Integration system was mainly only used to see if everything is built. There were no really data on it, so you could not really run tests on it. Then there was two consolidation systems where all the tests were happened, and then you had one pre-production and one production. Main challenge here was mostly one from the integration test and one from the consolidation was every time blocked for bug fix releases, for important fixes. So at the end, for really going forward with your development, you only really had one line for integration and consolidation. So it was every time hard, or it was every time the case, okay, first you must merge all your features together, and then it was not really possible to test features independently. Everything was first merged together, and when it comes, it needs also a lot of time from going from integration to consolidation, and only really on the consolidation the real testing could happen. The developer were already on a stage on the next feature, and then he gets the feedback or say, okay, something is not working, so he must go back to his previous task continue with this development and push this again, wait a long time, get at some point a feedback. So the moving forward with the features was quite slow, and the idea was, okay, of course we need one production and one staging, but to get to a setup that we have like n development landscape. So for each feature, we want to have a separate landscape so that we can also involve testers more early and do automated tests on it, and that we can really ensure as soon as a feature or as soon as a branch is created with a feature, there will be also the possibility to have a landscape for it, and not waiting, okay, hopefully I can test this soon, and not like testing it in 1 month. So yeah, this is a little bit more in detail. So we had the local development with all the features, then we merge everything together and have already a release. But integration, it was only, okay, it's merged, we can build it, but that's it. So there was not really testing. There was only really a small amount of data, not much to test. So then it goes to consolidation, and then the real testing starts. But here also was a problem. At that time, there was no really automated or not much automated testing. So it was really a lot of manual testing. The people were, or the testers in the process were coming in quite late in the process. And then it goes on staging, and there was also only the possibility to do manual testing. And when you're looking at it from a release offer, so you have the local development, do some units test probably, and then you go into the integration. But the real work comes on the acceptance or on the consolidation system. So then when something is moving from integration to consolidation, the testers really start, and they had a huge block what they must test, and then they had like a week to test, where they more or less were overbooked with test load, and then they had, when it's done and everything was successful, it goes into production, but then they had like, again, 1 or 2 weeks more or less nothing to do, and waiting for the next feature or next release, which comes to the acceptance phase. So the idea was also really, we must move this forward, must automate this to be more flexible in the future, and to push more features into production faster. So yeah, the idea is really have a local development with all the features, but then have a flexible dev environment. So for each feature, you can have your own branch, you can have your own development landscape. Also moving the organization in that way that you start automating tests and not do everything manually. So really start using the tools proper, that you automate as much as possible, and find issues as early as possible, not really on staging, try to find it already on local testing or latest on development, and fix it quite soon, so that the developer can really focusing on developing their feature to the end, and then it goes into production, and not starting with a feature, waiting until it's tested. In the meantime, you do some other features, and then at some point it comes back, and you first must like rethink, okay, what I did at this time, okay, going back in this process, okay, how do I continue, so that you really can focusing first, finishing one feature completely to the end, and then when it's tested, it's done, you can pick up a new feature and focusing on the new features, and you know, most of the time your old features will not come back because of any issues, probably because of new enhancements, new requirements, but not like, okay, doing ping pong. So really to move the acceptance test and move everything more to the beginning, and have more tests at the beginning, so that the move over from testing and from the feature, when it accepts all the tests, it's quite easy to get this into staging and production. And yeah, for this we started with Google Container Engine to use this as a way to deploy the features. So yeah, and now Thomas will continue and talk to you how does this look like.
Yeah. Okay. How does it look like for the developers now? First of all, I want to show you the network setup as it is for our Google Cloud project. On the left side, you see there are our old data centers. The one is the Water Bertelsmann. There is our main data center, and all of our development is placed. And the other data center is Conrad. So there's our subdata inside it, and both of them are connected through a side-to-side connection to a network here, to a VPN network. And also in that VPN network, we provided an OpenVPN server for our developers to get a secure connection to that network and to our networks inside that cloud project. And now to the cloud project. We have three other networks there. The one is the third-party network. There we have a Jira and a Confluence placed in, and that network is open and available over SSL. Then we have our VM network. That's our application network, and in that application network we migrate VMs or components from our Vato, for our old data center, to Google Cloud. And when the migration is finished, we try to containerize that things and move it into our Kubernetes cluster. Yeah, and on top we have our main network. In that network there is a Jenkins, and our Jenkins is for managing the tools in there, and also the builds and the deployment scripts are placed in the Jenkins. And and also we have our Kubernetes cluster in that network. So about our cluster setup, we use our namespaces. We name our namespaces as our Git branches. So every developer has his own feature branch, and he has his own namespace with all the pods in that he want to use, or he used to test that things.
So for each feature a developer is creating, or for each feature branch, we deploy the complete application for the developer in a complete separate namespaces. So the complete application is there, and we spin up one big Kubernetes cluster, and for a certain time, we will show it you later, the developer can say, okay, how long it should live, and then we run the complete infrastructure, and he can decide, okay, what type of application, so which feature I want to run, on which feature I want to be run on the middleware, on which feature I want to run the web shop itself, and can combine this dynamically together how the developer needs it for his test. And also, like, the cluster is set up in that way that it's automatically scale up. So based on the workload, it will scale up. And like in the evening or night, most of the namespaces are deleted, and the cluster is downsized, so that can ensure, or that we ensure also to save cost in that way. And in the morning, the developer says, okay, deploy it again, and then a few minutes later, he has this new testing infrastructure again.
Yeah, and you also see we have a connection from one namespace to another namespace. There's the search pod was missing in the right namespace. That's because nothing changed in that pod, and we don't need to deploy that every time. So the developer has the possibility to connect to a default component of that all things. Yeah, the next thing is our delivery pipeline. So that's the pipeline the developers go through to get their working infrastructure. First of all, we use Bitbucket as for our repositories, or Git repositories as management. And in that Bitbucket, we have found a plugin to create buttons and notifications behind that buttons. And the notifications will notify our Jenkins, and he will do some stuff. So here we have 5 buttons there, and on the right side we have our Google Cloud platform and our Jenkins with some build jobs and other jobs. So when the developer wants to compile his branch, he pressed the compile button, and the Jenkins jobs are running. And after the build is finished, the image is pushed to the container registry of Google. Now when they want to deploy that thing to Kubernetes, they press the deploy button. They also have the possibility to compile and deploy, so they don't need to wait till the compiling is finished. And that deployment script will grab that use that image in the container registry and deploy that to Kubernetes. So and then after the deployment, the developer will get an email with all the information he needs and can test now his branch. Then we also have the remove. But that's also possible to migrate your pull request, and then that namespace is also deleted. Then we have our automated testing in here also. That's had a notification to our Jenkins in our old infrastructure, and that Jenkins had a connection to our keyword-driven test server that's placed in Netcare, and that server has a connection to our VPN also, and can test that feature on that place there. So now I want to show you that things. So first of all, I will go to our Bitbucket, and in our Bitbucket there you see a pull request from some developers, now he wanna deploy that thing, so he goes through that to the buttons, and you see there there's a new version of our buttons. That's changed the last days. So now the developer has the possibility to check what system he wants. So I want to have my whole front end in it, and also middleware with price engine and runtime, and the data set for that things. And in the data set I want to have our testing users, our keyword-driven test users, and our integration test users. And here's the time to live, so I will place it, I will set it to 1 hour, because I don't want to have that thing after the presentation. So here I want to, I can create a custom namespace, but normally they will, the namespace is named by the feature branch. So here I type a custom namespace, kubecon demo, and will deploy that. So nothing will happen here. So the developer will get an email that the deployment is started, but we can look into our Jenkins. So here's the job that will get a notification when that thing is finished. And here you see that Jenkins job is started. On top you see a button is triggered, and the middleware deployment is already finished, and the front-end deployment is started. So let's see what parameters we provide to our Jenkins job. So prove that that plugin in our Bitbucket, all the information of the pull request is going to that job. Okay, and I want to see the front-end deployment will take a while. It takes 10 to 20 minutes, so I can't show you the success of that deployment, but we can look into our Kubernetes UI and look how the deployment is going. And let's take a quick refresh. So the namespace is placed in there. And here I found my, here's the kubecon demo. So let's see to the deployments, and you will see 57 seconds ago and a minute ago the deployment is started, and yeah, it's all up and running. So after all that thing, I will get an email from Jenkins, the deployment is finished, and I can test now that thing. So in that email there's a fast link to our shop, and I will check that really, that's not the right namespace. It was kube-con-demo, and
so as soon as the namespace is created, we also generate a load balancer for it, and also reconfigure automatically the DNS entry on Google Cloud, so that each namespace and each feature branch gets its own namespace with an own DNS entry, and you can access it from an external world. The only thing is we restrict it based on IP, so you need a VPN to go in, so that no real external can see new features which are coming in the future.
Okay, I will go to the site namespace I created before that presentation, because the frontend needs a little while to finish the deployment inside, so I can't show you that now. But I created a demo also on that thing before. I can show you the creation date of that thing. And yeah, on that side you can see the shop is usable, and the developer can now test that thing, and also our testers can test it, and he can start the automated tested from the pull request back there. So here is my demo I had. You see it ages an hour ago, and all that thing is running up, and yeah, it's possible to use now. Yeah, and that's more the presentation, the demo of that thing. And now we will come to our hacks we had to get all that things running correctly. So as I said before, we had a side-to-side connection from our Google Cloud project to our old data centers, and that thing was quite long till we get that thing, because our service providers had old firewalls and all that things, so it takes a while, and we needed to wait there, but we don't want it to wait, so we said just our Jenkins need access to our old infrastructure, so we based a client VPN for our old infrastructure in that Jenkins, and now we have access to our Bitbucket and to our network Nexus. The next thing we did is that we use Nginx as a reverse proxy for accessing our backend services, and the backend services are based in a Docker file, based in a Docker container.
Yeah, and on the application side, I mean, it's an old application. Everything is currently running on Oracle, so we need somehow adapt this onto the cloud world. On Google, it's still somehow hard to get Oracle running, but the good thing is we can reduce the size of the image, so we can use the Oracle Express version for the test environment, and run this inside the namespace. And in this kind, it's also not critical to run databases, because when it's crashed, okay, we will redeploy it, and it's nothing which must stay for long for the production. But it was a long discussion, and also a long way to figure out, okay, what we want to do with the database. There is now, the next step will be bringing some production into it, and for this there are some tasks to move forward with the database, and probably then we can get rid of the Oracle Express version, and probably move to some other databases which are a better fit on Kubernetes.
Yeah, that was our hacks we had there, and also we had some learnings through that whole project. As I said, the network connectivity is not to underestimate it, so don't see that thing too small.
Yeah, especially we had like 3 networks to maintain. Of course, on the Google Cloud it's quite easy, but we must get a commitment from the Conrad data center and from the service provider to get all connected together and to align this, also align how we do this, because of course we also don't want to like use several things to manage this. So to get alignment there to say, okay, how we manage this, how we do this also on a proper setup for the future took some time to do.
Yeah. And the next thing is that AEM is pain, so we use AEM as a front-end system, and that AEM has a huge repo size. In our case, that's more like 100 gigabytes to 200 gigabytes. That's all the assets that are placed in there, and every component of AEM needs his own repo, and it can't be shared with the other publishers or authors, and that's a big, not so cool in that thing.
So who are not familiar with AEM, it's Adobe Enterprise Content Manager. Currently it's not really built or designed for running in container. We must did some hacky things. With a new version, they're planning to support Docker, and we hopefully also get rid of the huge image size. But we also had the discussion internally, does it make sense to containerize this? Does it really make sense? Or should we use plain VMs for it? But at the end we decide, okay, it makes no difference if we ship a huge container or if we should ship a huge image. We must ship this big size of data, and there is not really a way around. So we decide, okay, probably it's not best practice for containers to do this, but images also will not bring a better way. So we say, okay, then let's do this with bigger images on Docker. But then we have a aligned workflow for all the systems we are using in our workflow, and we can, for the deployment, we can completely use Kubernetes.
Yeah, and also we had a thing that we used to have a build of that front end with our whole assets we stored. And that build takes more than 8 hours, and so we just can run that thing on the weekend and had a fresh base image on every Monday. Yeah, and another thing we did, we wanted to secure our network over OpenVPN. First of all, we created there just a VM and tried to manage that thing. But we said, and we found out that management of that OpenVPN is quite a lot, and we don't want it to manage everything there and create a user with manual impact. So with the help of Loodse, we created that OpenVPN inside of a Docker and automated all that process from the creation till the information to the developers. So we just can go into our Jenkins, type the email address and the name of that person, and he will get an email with all the information he needs and the configuration for his OpenVPN.
Yeah, and because we started with all this containerizing, the complete application, also the developers picked it up quite fast and started using container in their local development workflow. But especially with the huge repository size of AEM and all this other images, we figured out, okay, downloading every time the images from the Google registry locally is probably not the best way. So what we set up is also a local mirror for the images for the registry, so that we only download it once and not for every developer everything goes over the internet to download it. And that was it. So that's mainly mainly the idea is really run for each feature, running it in a Kubernetes namespace, completely separated, and then it's quite easy to scale this on the cluster-wise, and scale this also on the feature-wise, and really help to enable the developers to concentrate on their features and don't waiting for infrastructure if they are available. Thanks. Do you have? Do you have any questions? Yes.
So basically, you have just one cluster, right? And and different namespaces for like production, video, and feature branches.
Yeah.
Right? So how do you then operate the Kubernetes itself? So how does it work?
Because we are on Google Container Engine, we...
Sorry, can you please repeat the question?
Sorry. The question is because all of our feature branches are on the same cluster, but it's only feature, it's not production.
Okay, production has a separate cluster.
No, currently it's production is still separated. Production runs still the old way. Yeah, currently upgrading the cluster, it's not so critical because only the feature branch is on it. There is currently the process to move production also into the Google Cloud, but there's still the question how we run this in production. Do we put everything in container? Probably not. Like AEM currently, it's not built for it. So definitely, this is definitely a learning from it. You cannot run AEM in production in that way. It will not work. So there's currently a discussion how to build up a production environment, and definitely we will divide it in different clusters then. So have production in a separate cluster. Yes.
Where exactly did you run your own instances of Scheele and Confluence, or was that managed? I didn't.
Yeah, it's all self-hosted of Jira and Confluence.
So the question was if we run the instances Jira and Confluence self-hosted or hosted or self-hosted on our own. It's everything runs on Google platform, yeah, self-hosted. Yes?
Do you use Jenkins Kubernetes plugin, or which creates Jenkins like on the fly, or?
Yeah, we just use kube control. So we don't have Kubernetes plugin in our Jenkins.
Pipeline, do you use like a pipeline plugin to script all?
Yes.
Yes.
In Jenkins, we scripted all of our configurations, and we used the pipeline script of Jenkins.
So that was on the one slide you saw. Here are two Jenkins. On the left one you have the old Jenkins, and this was completely not scripted. And when we started, we said, okay, no, we don't want to go in the old environment. We want to use Jenkins files and build it properly. And that's the reason why we have a separate Jenkins only for the stuff. And now probably moving more and more and stuff over, but don't do it manually. So really do use Jenkins files and script everything. Yes?
You said you use kube control for making the deployment itself. So how do you manage the app configurations or service configurations and secrets?
I mean, secrets, it don't must be secret. So what currently Helm was not at that stage that we can use it. So we do some regex and replacing some value. Probably that would be a next step to, instead of using kubectl and do our own logic there, have a value file and using Helm for it. Could be a logical step, but when we started roundabout, yeah.
So basically an interface with an application.
Yes. Oh, no, there's a separate repository where all the manifests and all the application is described, and this is deployed. Yeah.
I think I saw this on a previous slide, but I just want to double check. You only have a handful of services, right? We're not talking about 20 or 30 microservices. So if the developer is working on a feature, he's usually only changing one thing. So
We are talking about, the question was how many services we have there in our system. We have quite a lot services there. It's around 20. So yes, we have that many services. Yeah.
are they all in the same repository?
They are all in the same repository. That's not separated from microservices.
And this is also the idea behind this, why to do this, to have in the future more and more services and scale the services also, because it's coming more from a monolith with some bigger services, but not really microservices. Now it's getting more and more services. So, but in the future it could be 100 services, and this you don't want to manage manually. And this was also one intention to say, okay, we want to have a flexible environment for this.
And then when you set up an environment, it takes all the services with like a fresh copy of all the services.
Yeah. Yes.
That means you're building every image in every pull request, or you put the application of the image?
We build a base image of everything, and on the build we just use that base image and makes just a simple deployment on that base image and created a new image with version of the namespace of that branch. So yes.
But really depending on which services you are working. So like when you like building for the front end, we only build the image new for the front end. So all the other things, we use the existing one where you can say, okay, I want to use version X from the middleware and version Z from the search.
Okay, but if you change some dependency for the front end, what you are doing? I mean, in the base image you have 5 dependencies, but in some feature branch you want to change one thing.
Yeah. So I mean, it's mostly with IAM where we have the problems with the base image because there the build is taking quite long. For the rest, it's not a problem to build everything, but for IAM, it's also not so.
Yeah, IAM we have on the Jenkins shop we have a possibility to connect to another namespace. So on the deployment, on the build, it will change the dependency to that false middleware or what else. Yeah, but it's not possible for the developers right now. So we are updating that thing, and maybe it's possible in the future. Okay.
Yes.
Do you run a branch per platform, or do you just Jenkins a master? The fixed branch is master, or do you run a branch per platform?
Can you repeat that thing? I don't hear it.
Sorry. So when you're doing the feature branches,
Yeah.
you check out from master and everything else?
No. The master is just for the production. We use our develop as our default branch. So develop is our up-to-date branch.
So we're following Git flow.
Yeah.
Yeah. Yeah.
How do you implement hotfixes? So when something happens on the production, you need to fix it on the previous version and then merge it to all the existing branches. And then, then make it new release.
So the plan is to have the develop on an up-to-date state and always runnable on production. So as I said, we had the pull request to the develop, and on the pull request, everything needs to be tested and fixed till the end. So the develop is always open for a hotfix, and when we have a hotfix, it get the same pipeline, and it can be deployed then. Yeah? Again, yeah?
How do you, when it's fixed, are you creating a new release in
Yeah.
or
That our whole thing is not running so long. So it's also in the alpha beta status. So we don't have a hotfix yet. So I hope that's good. Yeah, but yeah.
So currently the existing language is also running in parallel now, also, so we can go back to the old system. This is mainly focusing is currently for the feature, but yeah, the next step is involving this, bring this completely, integrate this in the flow. And one topic is also where we're currently in discussion completely, how do we do hop fixing, how, especially not from the infrastructure, from the process side, which branch will be up-to-date branch and how to do this and how to merge this in every branch. Yeah.
I love what you guys are doing. I have a question about developer adoption and the cultural change that you guys are going through. I'd love to hear a little bit more just what that's been like for you guys.
As we said, that process is still in process. That thing is still in process. It's for us. It's quite hard. We come from an old way to work, and that's a new agile way. Is a thing it's hard for us. So we don't use the perfect way now. So we are in the migration now. But it's hard, yes.
And Yeah, as I said, it's really not only the infrastructure. So we must do really marketing internally into the organization to say, okay, what are the benefits of this infrastructure? Why it makes sense to use this, and of course it will change your process and it will change how your flow, how to develop. But the benefit is you get much more benefits out of it, that you can be concentrate really on a feature, develop it to the end, and not like waiting for a feedback 2 weeks, 4 weeks later, and then doing things, because this was every time in the past the feedback. Okay, we must wait too long to get feedback, and then we are in a completely different topic and must go back to the old topic, and you mostly don't know exactly. Okay. Or you start first, must thinking, okay, what we did in the past and going into this, and now it's really really to push the development and make like marketing around it and say, hey, that's the new cool thing, have a look at it, how can we help you to improve your ways? And now it's going from one organization to another, and try to pick them up and say, okay, use this as a new way, especially when in the future the development comes. Okay. I think we are now also at the end. So if you have questions, come to us. We are here, so we can still talk to you.